Good morning, everyone. Thanks for joining us today for this webinar on the AEC Workflow Structure Engineers. Before we begin, a couple of notes about Excitec as a company. I should introduce myself. I'm Billy Sherrard. I'm the Autodesk Product Manager with Excitec. And Excitec, yes, so we've been in business for over 30 years now, and not just a Platinum Autodesk reseller, but also working with our customers in a number of different fields, such as IT, consultancy, document management, facilities management, and basically service the whole AEC construction industry from conceptual design all the way through to handover facilities management. A couple of notes. You will see from our website, from a lot of the material that we produce now, some animal imagery. Just a quick note on that represents our brand ethos of the synergy and close symbiotic relationship we hold with our customers. Now, without further ado, what I will do, I'll pop over to my colleague, Lawrence Hooker, Technical Consultant at Excitec, and we'll begin the main session. Thank you.
Good morning, everybody. So we'll just move forward. You can see what's on the agenda here. We have three workflows that we're going to present to you. So we have a structural space frame, which will be using Revit and Dynamo, and also a bit of robot as well. We then have a retaining wall, which we're going to start off in Civil 3D and then bring across into Revit. And finally, we have a steel frame, which we're going to look at the interoperability between Revit and Advanced Steel. Okay, so what you're seeing here is the Autodesk AEC Collection as it stands at present. Now, you'll see that I've got two swim lanes here. The lane on the left-hand side here is showing us the prevalent tools for structures. So you can see here we have Revit and Robot, Advanced Steel, AutoCAD, Dynamo, Civil 3D. These are the tools that we see as being the maximum use that you can get out of the AEC Collection for structures. The tools on the right-hand side you also have, but you may use them a little less. But it's not to say you wouldn't use any of those tools there. Okay. One other thing to note, the AEC Collection now contains something called One AutoCAD, and One AutoCAD now is an amalgamation of all of these tools here. So many of you may have been used to AutoCAD Architecture, or used to be Architectural Desktop, AutoCAD MEP, MAP, raster design for processing paper drawings and vectorizing them. All of these tool sets are now available in One AutoCAD. So when we refer to One AutoCAD, we're really talking about that entire tool set there. So that's just something to note. So without further ado, let's go straight into our first workflow. So you can see the products that we're going to be looking at here are going to be Revit. We then go into Dynamo. What that's then going to do is drive Robot and Revit together. So you'll see the output is shared between Robot Structural Analysis Professional and Revit. So what we're going to do is we're going to take a very simple structure, as you can see here. What I have is a Revit mass that's sitting over the roof here. What we then do is use Dynamo to pick that face on top of that mass. And the Dynamo graph is going to generate the space frame, the structural space frame, and it would also generate the same structural space frame in Robot Structural Analysis. But what it's then doing is also adding loads. So in this case, I'm adding a snow load to the roof. It's then also creating panels where I can actually host loads and so on, and then designing the roof, and then finally we're putting all of that back into Revit. Now, for those of you that may not want to be using things like Dynamo, you can see here that we have an AutoCAD workflow. So here what we're doing is taking the Revit model into CAD, and then in AutoCAD here you can see that I'm using SurfTab 1 and SurfTab 2 to control faceting over that roof. So that's another option if you don't particularly want to go down the Dynamo route. So let's now have a look at this in the product itself. So we're starting off in Revit at the minute. This is 2019.1, so if any of you saw that that different front screen there, that's the new addition to 2019.1. Here's the mass we talked about. You can see I can just edit this in place. I can select the grip, and then we can use the shape handle there just to change the shape of the roof. So that's just a simple massing component there. Now that we've done that, what we can then do is get on with the business of starting up Dynamo. So you can see I've got two versions installed in my machine. I'm just going to go ahead and use the Dynamo 1.3. That's the version we'll go ahead and use. Okay, now I will open up a script that we've already got. So here's the Dynamo script. First thing we'll do is we'll run it, and then we'll look at how we can go through the Dynamo script and show you how it works. So we'll just run the script first. Notice here that I have robot structural analysis shown on the screen as well. So as I said, it's going to feed data back into Revit and robot structural analysis concurrently. Now this is all obviously running in real time, so there will be a slight delay while Dynamo calculates the space frame and puts all of the data back into the relevant applications. Notice with Dynamo as well, I've actually split the graphs out, so I have these this kind of purple, orange and green color here just to collect the nodes, but you can see it's not a huge Dynamo graph. So here we have the space frame sitting inside Revit. Okay, so there it is. Now obviously that is linked to the surface and the mass we created. Let's take a look in Robot, and you can see we've got exactly the same structural space frame and also the panelization. I'm just expanding the bars here, and you can now see all of the bars and all of the nodes that have been generated from that same Dynamo script. Notice we've also got the snow load in there as well, which has been calculated and added to every single bar. Okay, so what would happen if we wanted to make a change to this? Now obviously without this workflow this would be a huge task, but you can see here that I can just access the mass. We'll just go ahead and edit that mass. Select the grip again. I'm just going to increase the height of this mass. Go ahead and finish that. What we need to do is just rerun Dynamo, so I'm just pressing F5 there just to get that to refresh and rerun. And what should happen is the roof will update to the Revit mass and of course update the robot structural analysis model as well. So there's the update in Revit that you can see here. Yep, so that's all looking quite nice. And if we just go back into Robot, you can see again the robot model's updated and all of the panelization has rebuilt as well. Okay, so there's our first workflow. So let's move on to the second workflow. So this one is looking at a retaining wall design. So traditionally we would create retaining walls perhaps in, well, we try and create them in Revit, but really I think it's got to start in Civil 3D. Now the advantage of using Civil 3D is we have the existing ground, we have the proposed or new ground, we can do all of our earthworks around the retaining wall and also optimize the perfect shape for that retaining wall. What we're then doing is using a brand new workflow where we can take the Civil 3D surfaces across via BIM 360 into Revit. So if the surface changes in Civil 3D, it will automatically update and change in Revit. Now, it's quite an interesting little workflow. So here you can see it in images. So we start off in Civil 3D in the top left hand corner. You can see what's then happening is we're creating a corridor from that. I'm then creating a solid model from the corridor. That is then put into a family file, which I'll talk about a bit later on. What we're then doing is we're transferring the surfaces and everything else into BIM 360, and that then goes into Revit. So you can see in Revit here we have some details with reinforcement and the footing of the retaining wall. If you look at the image below that, the 3D image, you can see that we have all of our reinforcement there in 3D, as well as the physical concrete items as well. And obviously the section there is cutting through the actual surface that's come from Civil 3D. In the bottom left-hand corner, you can see that we have our vertical design. So that's actually showing us the existing ground profile, the steps, and the actual level we want the wall to be at, and then a sub-assembly that I've used. So let's take a look at this inside the product. So here we are in Civil 3D. So you can see in Civil 3D here, if I just flip this into the 3D mode here, we have an existing ground profile. You can see that I have my retaining wall corridor and the corridor solids actually being shown here. So let's have a look at some of the components here. You can see that this is the vertical design. So the green dotted line is our existing ground. That red line is our height and the footing level. And here's my sub-assembly for the retaining wall. I'm just going to edit the corridor here so you can see how this is built up. So we go into the properties, and you can see what I've done is I've got the corridor and I've split it across the stations to allow me to have steps. There's targets in here, so the top of foundation is targeting the top of footing. This one is targeting the top of the wall. Okay, so then the main components. Now, what will also happen here, if we could just go back and select this, we're going to extract the corridor solids from it. So when you extract corridor solids, this takes the Civil 3D surfaces and creates a physical solid model that's inserted into the same drawing. Now, once we have that, we obviously need to go ahead and be able to use that inside Revit. Okay, so let's start with the Collaborate tool. So what we're going to do now is publish out the surfaces, as we've said, to BIM 360. This is really a very interesting workflow. So you can see I'm taking my proposed ground or my finished ground in here. We can then choose our folder where we're going to store this. Now look here, you can see I can access my BIM 360 folder directly from Windows Explorer, which is really, really good. Yeah, we just go into our folder where we want to put this. It's using Desktop Connector, which is a fairly new technology. So you can see I've saved that. That's just saved that locally, but the Desktop Connector, as you're going to see in a minute, will actually show us synchronizing this. So here's our pending actions in the connector. And in a few seconds, you should see that pop up on the screen. Okay, it'll just take a few seconds. There we are. And you can see that's now running. Yeah, and again, that'll just take a few more seconds. What's going to happen here is it's going to synchronize the desktop connector and publish that into BIM 360. So what we'll do here is just refresh this. So let's just go into here. Can you now see that that's rebuilding that webinar surface model? Yep, so that's now just refreshing. If I click it now in BIM 360, you can see the surface. Now that's a plan view, so what we'll do is we'll just go in and look at this in 3D instead. Okay, there's our 3D model being displayed inside there, so that's just a preview. This is using DWF technology actually, for those of you that might not have seen BIM 360 before. We have all of our information on there as well, so I have my surface areas, my properties, and so on, how many triangles I've got in there. Yeah, which is all quite useful to know. Okay, so that's just really checked that that surface exists in BIM 360. Let's now go into Revit. So first thing we'll do is create our new model. Now what I'm doing here is using our RC detailing template because I'm going to obviously reinforce this. There's our project datum. Now you'll see what happens is obviously I want to make sure that we are synchronized as far as coordinates goes. So you'll see here I've just taken an underlay out of Civil 3D and I'm going to move that to my chainage start point, which is 0, 0. So let's put that in there. We can then acquire the coordinates from that. Now this is a clever bit. So if we say acquire the coordinates, if you now look at my project base point, you'll now see that we have the easting and the northing and the level simply snapshotted from that DWG. So we're now coordinated. We have the same levels and coordinates shown. The next thing we're going to do is we're going to steal that solid geometry from Civil 3D. Yeah, so we're going to go ahead and select all the solids, which will be the corridor solids from Civil. Notice I'm also picking the datum as well. That's the sold area of truth. I'll know where that is inside Revit. So it's important to do that when you take information from Civil. You've got to make sure that you have a common datum. Okay, so you'll notice that's gone out in meters because obviously we work in meters in Civil 3D. We normally work in millimeters in Revit. So let's see what we do with this. Well, I'm going to create a new family because I want to be able to classify this. I don't just want it to be a solid lump of something. We'll import the CAD through. Let's go ahead and find that. That's going to go in center to center. Notice I've got auto detect on. So now, because this project is done in millimeters, Revit's automatically scaled that by 1000. We'll then move it to our required datum point. There it is. Okay, let's just take a look at that in 3D. And you can see there's our retaining wall family sitting in there. This is a crucial step. I've exploded it. That is now a Revit solid. What I can then do is create a subcategory from this. So let's go ahead and do that. So this is going to classify it. So we say it's a retaining wall. And obviously in here we can have a different projection and cut line. So it appears correctly. I can assign a default material. So we could say it's concrete or whatever we want to do here. So let's go ahead and search for concrete. Now obviously it didn't exist in the template. So I'm just going into my materials library and we'll grab a particular grade of concrete from there. Let's give it hatch pattern as well so we can actually see what's happening. So we'll make that nice solid grey fill. And finally, we've got to now apply that subcategory to that solid. Okay, so there it is. There's our corridor solid. I'm just going to save this out as a family here. Notice it's going out as an RFA file. And then we'll load that into our project. Now, of course, this is where the datum comes into hand, because I can just snap that directly over my project base point, and that is perfectly coordinated. Yeah. Okay, let's take a look at that in 3D at the minute. So obviously all we've got at the minute is our retaining wall, nothing else going on in there at the minute. What we can now do is use the new tool, Link Topography. So this is going back to my BIM 360 folder, and I'm now going to link in that Civil 3D surface. Yeah, so if we just bring that in now, just saying it doesn't share the same coordinates, so I'm going to align them. And of course, what's going to happen is it's going to align absolutely perfectly to our coordinates that we've set up. Yep, there's our topo inside here. Okay, what I'll probably need to do here, that's not quite right, so we just need to change the level that that's assigned to. So that was level 1 in this case. Yeah, and you can then see our retaining wall. Now, we'll move forward a little bit more, and you can see here I've gone in and reinforced some of this wall now, just so you can see the workflow here. Let's just take a look at some of the outputs that we can achieve with this. So obviously I've still got my topo in there, but you can now see I've got all of my reinforcement modelled in there as well. So obviously this this Civil 3D solid we can actually reinforce. There's my bar bending details in there. Oops, let's just move the total weight out of there as well. There we are, so we can see that a bit better now. There's a bar bending schedule, total weight for all of the reinforcement in there. If we just look at a drawing sheet here, yeah, they're the sort of outputs we can expect. So you can see I've got a weep hole in there at the bottom of the retaining wall. That's actually been modelled in. So everything, you know, the workflow has worked really nicely, going from Civil 3D, BIM 360 into our Revit model. The other good thing to remember is if I tweak and change that Civil 3D surface, it will automatically update our Revit model because it's hosted in BIM 360. Okay, good. So let's now move on to our next workflow. So the final one here is going to be working in our steel frame area here. And here we're dealing with two products, of course. We have Revit and Advanced Steel. So some of you may be aware that if you go back to a couple of years back, we had the introduction of structural connections inside of Revit. Now, these were designed around the Advanced Steel interface here. And over the years, they've improved and improved. And you can see on the left-hand side here, we have a Revit steel frame with some connections in. On the right-hand side, I've now ported that across to Advanced Steel. And all the connections are now put onto the model. Why would we want to do that? Well, of course, if we transfer something into Advanced Steel, we can go into much greater detail on a steel design. So if you're a consulting engineer, you might look at this and think, well, I don't design connections. It doesn't really matter to me. But sometimes you will. You know, sometimes there'll be a project where you do need to create accurate details on connections. And the advantage with Advanced Steel, not only does it do the 3D model, but it will create a fabrication drawings, as you can see on the left-hand side there. And all of that is completely automatic. You haven't had to sit there and detail the hole positions, plate sizes, chamfers, and so on. The other big thing with this is you can now see that we can get some very accurate cutting lists out here. So we've got a beam saw list, as you can see there. And the nice thing with the saw list is you can see that we get the saw length, we get the section size, shape, and everything we need to go ahead and physically fabricate that steel frame. The other great thing with Advanced Steel as well is if you make a change in Revit, you can synchronize the Revit model back into Advanced Steel, and you can very easily then see the drawings that are up to date, the green tick, and the drawings that require an update, the one with the little red question mark there. Yep. So that's a really nice thing as well. You can see how many new drawings you'd have to reissue out. So let's take a look at this again in the products themselves. So here we are inside Revit. And I've just selected a connection here. Here's the macros that you can see that will build the connection. So we can just go through and see all of the settings in here. Let's go ahead and look at a connection that didn't work out quite so well. So here we have a haunch on there. And you can see probably from the bolts there, that wasn't particularly great. But that's what we're going to fix in Advanced Steel. So we start by exporting. Here we've got an SMLX file, which is a structural markup language file, essentially an XML file. So we start by exporting that out of Revit. Okay, so the export's done. Let's now switch into Advanced Steel. We'll create a new document from first principles. And we'll start by importing that SMLX file. Now, when we import this, you'll see that Advanced Steel will then build that same steel model inside its interface here. Now, if there's any sections or materials that it couldn't map across, it will prompt you with a dialog box, and then you'd have to actually manually map those. So if it didn't understand a particular section in Revit, we'd map it. But in this case, it's all fairly straightforward. So you can see here, all of that's been mapped perfectly. Notice all the connections have been ported through. So let's just go ahead and shade this model, and we'll zoom into the same connection, and you can see there it is. Let's run the same macro up in Advanced Steel using the joint properties, and you can see we've got exactly the same set of settings and values that are used inside Revit. Let's look at the bad connection up here. Yeah, you can see the bolts aren't quite working there. So what's actually happening there is the bolts are way too close to the edge. If we look at some of the properties inside the joint setting here, yeah, see the bolts are almost at the edge of the plate, so clearly that's not going to work for us. So what we can do is we can make our changes and edits inside Advanced Steel. Okay, so we just lengthened the haunch. Now what we'll do is we'll start to deal with the bolt diameter, so we'll increase that to an M24. Perhaps we want to increase the bolt count as well. Change the dimensions from the top and the bottom there. So in this case, we're having 3 bolts at the top and hopefully 3 bolts at the bottom as well. So you can see we'll just tweak those dimensions until we get something feasible in here. Okay, and then we can add our 3rd bolt to group 2. So you can now see we've got 3 bolts on group 2. So there's the bolts, but of course the plate still needs some attention. So we'll go back to our end plate, and you can see here the width isn't big enough, so just increase the width out. That's looking a bit more reasonable. But obviously here we need some space to get a weld in between the haunch and the end plate. So what we can then do is increase the projection at the top of the plate and also the projection at the bottom. You can now see we've got some space in there to get a weld across the bottom of the haunch there. Okay, so that's looking good, but of course, if you look on the left-hand side here, you'll see that haunch has not changed. So we can add these to a joint group. This is one of the big advantages of Advanced Steel. I can link these joints together. Yeah, so if I do that, if you take a look at the joint on the left-hand side, can you now see that synchronized back to the first joint? So now if I change the first joint, all the other joints in that joint group would automatically update. And that's something you can't do in Revit, so that's very useful. So what we now do is export this back out. Obviously, we've made our design change in there. So I've just called that Advanced Steel out or AS out. Same SMLX file. There goes the export. Okay. All good. Okay. That's just asking me to save the model because I started a new model from scratch. I haven't actually physically saved the Advanced Steel model yet. So we go ahead and save that and switch back into Revit. So now what do? Well, we synchronize now. We don't want to re-import it through. We've already done that. But what we want to do is synchronize the changes back into the model. So you can see there's the bad haunch with the bad design. We'll pick our Advanced Steel SMLX file. We should better now click open on that one. And it's now going to use the synchronization dialog box. So in here I can see things that have been modified and deleted and changed and so on. So actually all I'm interested in here is the connections. Let's apply those. And that will update my Revit model. So again, I'm in synchronization there. So, you know, if you are working with a separate fabricator and they've made that design change, we can just synchronize our steel model back to the Advanced Steel model. So now I have an up-to-date set of details in Revit, which is very, very useful. Again, if I edited that, I would see all of those settings inside the connection. Let's go back into Advanced Steel. We'll look at some additional features in here. So I'm going to start by numbering up every single component in here. Again, this is something Revit will struggle with, unless you use something like Dynamo. So you can see here, it's now marked up everything according to whether it's a beam, a column, a plate, and so on. We can then use some drawing processes. So what this is going to do is I'm actually going to say, right, well, let's get all of the parts out of here. Yep, so there's selected single parts. In this case, I'm going to say all single parts. Yep, so all SP, which means all single parts there. Go ahead and create all the drawings. Now this will take a little while. So what Advanced Steel is now doing is taking every single component that makes up that steel frame and creating drawings from it, but they're fabrication drawings. So this is the big difference between Advanced Steel and Revit. In Revit, I would simply create a section or an elevation. Here's our assembled frame. Advanced Steel is going to create details of every single component. You'll see that it manages how they're going to fit onto drawing sheets as well. It will add all the dimensions, bit of materials, cutting lists, absolutely everything I need to create this. Now, the other thing it's generated in the background here are all of the DXF files and CNC files used to drive machine tools. Yeah, so I could actually use laser cutters, automatic punching tools directly from the Advanced Steel code. So that's now done. So let's go and take a look in the document manager. And if we just expand our drawings in here, yeah, you can see they're all up to date, obviously, because I've just created them. And it's just now created all these automatically. So let's take a look at some of them. Makes a pretty good job of detailing out all of that steel, as you can see here. Yeah, so everything's dimensioned. If we go down and look at some of the CNC files in here, so this is the DSTV NC files. Let's pick on one of those. Let's take a look at a preview on the code. That's the CNC code for that particular component. Let's look at a drawing exchange format file. So we could use this for a laser cutter or something. There it is. Notice that we have the mark of the object in there and then the footprint of the column in this case, so the laser could actually mark that out as well to assist steel erection. Okay, so what happens if we make a change? Well, let's have a look. So what we're going to do is, again, focus in on this haunch. Yeah, so there's the haunched connection in there. Perhaps what we'll do is we'll change the bolt configuration again, because that's obviously going to change the holes in the plate. So if we make, if we say there's 2 holes now, obviously we'll have to change the spacings a little bit now to compensate for that as well. So there we are. We've now got 2 bolts at the bottom. Let's just tweak the space in there a little bit as well. Get this centered up a bit better. Okay, and what we'll do, let's also change the end plate as well. So we'll give the bottom a bigger projection, as you can see there. Right, so that's changed the plate size and the whole configuration on the plate. Bear in mind there was 2 connections that are synchronized, as you can see. But what's happened to the fab drawings? Well, let's have a look, because obviously they're not all updated, just a few. This is where Advanced Steel is really useful. Can you now see that I've got 3 drawings that require an update? So if I've already issued the drawings out, I need to reissue those 3 drawings because these things have changed. Now, what becomes really handy is once we've actually reviewed the drawings that the changes are happening on, I can actually get it to revise these automatically and cloud where the changes have happened. So let's have a look at this. So what we'll do here is we'll go ahead and create a revision on this. Oops, just need to revise it first, of course. So let's go ahead and create the revision. So it's revision A, and I can put in a bit of description. Whoop, let's get caps lock on. So I haven't got that on at the minute. There we are. So we moved holes and changed hole spacing. Okay, so that change has now gone through. Now, what's quite clever, well, let's just go back into the revised drawing. Now, notice it's up issued it to revision A in the list there, but can you see the clouds? So Advanced Steel has now clouded up everything that's changed automatically. I haven't had to interact with that at all. Perfect, so that's exactly what I want. Now, what we can then do is, let's just force the update first. So you'll see that that's now going to force that across. Notice now revision A appears in the list of up-to-date drawings, and I can now say that's been approved. And you'll see a little green dot appear on the drawing manager there. Yep, and there we are. So we've now managed that change very, very easily. That would have been difficult to do in Revit. Okay, good. So there's our 3rd and final workflow. So hope that's been useful. Obviously, there's lots of other workflows that we can look at in due course, but they're the 3 that I thought I'd like to share with you. So I think we'll finish it there. So thank you very much for attending. Really good to see so many of you on the web session here. Like I've said, if there is any questions you've got after this, you can obviously email us with those. Many of you will know me on social media and so on, so you can contact me there if you want to as well. Thanks for listening. As I say, hopefully we'll better do some more of these on some other interesting workflows. Thanks very much.